All right, let's get into it. Think of yourself as a detective for a minute. We've got a case, and our main suspects are a couple of linear equations. So what's our mission? It's to find that one single point, that one location that they both have in common. This isn't just about crunching numbers, it's an investigation.
So here's the big mystery we're tackling. Just picture two perfectly straight roads stretching out forever. The question is, do they ever cross? And if they do, where exactly is that spot? That single intersection point, that's our solution. It's the scene of the crime where it all lines up. And finding it, that's our entire goal here.
You know, before we dive into any investigation, we gotta know the possible outcomes, right? So with two lines, there are really only three things that can happen. First, and this is the most common, our lines cross at exactly one point. That gives us a single, unique solution. Second, the lines could be the same line just in disguise. In that case, they share an infinite number of points. And the third possibility? The lines are parallel. They run side by side forever, but they never ever cross. No solution there.
Okay, so what's the first tool in our kit? Well, every good detective needs a map of the area. And that's exactly what this method is. We're going to solve this visually by graphing the lines to see the whole picture at once.
Honestly, the logic behind this is just so simple and intuitive. You take your two equations, your two suspects, if you will, and you just plot their paths on a grid. Once you've drawn both lines, you just look. You look for the exact spot where their paths intersect. No crazy calculations, just good old-fashioned visual evidence.
And here we go. You can see it right here in action. We've got our two equations, and they've been plotted out for us on the graph. You can literally see with your own eyes where they cross. And boom, X marks the spot, right at the coordinates 2, -1. It's a fantastic visual, but you might be thinking, what if it's not a perfect whole number? What if we need to be more precise?
That's a great question. A map is awesome for getting the lay of the land, but sometimes it's not precise enough. For that, we need to bring our suspects in for a little questioning. It's time to break out our algebraic tools and get an exact confession.
Our first interrogation technique is called the substitution method. Here's a way to think about it. You get one equation to tell you its secret, like what y equals all by itself. Then you take that secret and you plug it into the other equation to make it spill the beans and reveal the rest of the information.
So here's the four-step game plan. First, you get one variable completely alone on one side of the equal sign. Step 2, you take that expression and plug it into the second equation. Third, you solve that new equation, which is now way simpler. And finally, you take that answer and use it to figure out the value of the other variable. It's a really clean and logical process.
Okay, let's watch this technique work on the same case from our map. See how the first equation gets rearranged to isolate y? That piece, 2x minus 5, then gets substituted for the y in the other equation. After a little bit of algebra, the equation basically confesses. X has to be 2. You plug that back in, and it confirms y is -1. The evidence is solid. It's the exact same solution our map pointed us to.
But what if isolating a variable looks like it's going to be messy? No problem. We've got another technique in our toolkit, elimination. This one is super clever. The whole goal is to line up your equations and then add them together in such a way that one of the variables just disappears. It's gone. Eliminated from the investigation.
Here's the playbook for elimination. First, you stack the equations up so they're perfectly aligned. Now, the key move is step 2. You might need to multiply one whole equation by a number to make sure one variable has opposite coefficients, like a positive 2x in one and a negative 2x in the other. Then, you just add them up, solve for what's left, and find your missing piece.
Let's see this in action on our case. Check it out. We multiply that second equation by -2. Why? Because that changes the x into a -2x, which is the perfect opposite of the 2x in the top equation. So when we add the two equations together, poof, the x's cancel out completely. We can quickly solve for y, plug that back in, and we get the same confession. The solution is 2, -1.
And this is the big takeaway, right? It doesn't matter which tool you pull from your detective's kit, whether it's the map, substitution, or elimination. They're all just different paths that lead to the exact same truth. Our solution of 2, -1 is rock solid.
So, you might be wondering, how do I know which tool to use? Well, it's all about working smarter, not harder.
If you look at the equations and see a variable that's super easy to get by itself, like a plain x or y, substitution is probably your best bet. But if the equations are already lined up nicely, elimination is often the faster way to go. Just remember, isolate and replace, or stack and cancel.
All right, detective. We've practiced with our tools in a controlled environment. Now, it's time to hit the streets and solve a case that's disguised in everyday language. Yep, we're talking about word problems. Okay, here's the case file. We're looking for a mystery 2-digit number. We've got 2 clues to work with. First, there's a relationship between its 2 digits. And second, we know what happens when you swap those digits around. This is exactly the kind of puzzle these tools were made for.
You know, the most critical part of cracking these cases is always the first step, translating the clues, the words, into hard evidence, the math. This little table here is the key to the whole thing. If we say the units digit is x and the tens digit is y, then the actual value of the number isn't just yx, it's 10y plus x. Getting that right is everything.
So let's turn our clues into equations. Clue number 1, the tens digit is twice its units digit, translates perfectly to our first equation, y equals 2x. Easy enough. Clue number 2, about reversing the digits, gives us that second, more complicated equation. And as you can see, we can solve this system using substitution, because we already have y isolated. The math does its thing and reveals that x is 3 and y is 6. So the original number, 10y plus x, was 63 the whole time. Case closed.
And hey, here's a pro tip for you. Every good detective double-checks their work, right? So after you've done all of the heavy lifting, think of a calculator's equation solver as your own personal forensics lab. It's the perfect way to confirm your solution and make sure your investigation was totally on point.
So there you have it. You've got the map, you've got the interrogation techniques, and you've cracked a real case. You're not just a math student anymore, you're a mathematical detective. This toolkit is all yours now, so the only question left is, what mysteries are you going to solve with it?